Hey everyone, welcome back to our third lesson in Unit A. This lesson is number 3, called Separation Techniques. So before we get started, quick recap from last video. We talked about the classifications of matter. We had that lovely flow chart. We talked briefly about the different types of mixtures, homogeneous versus heterogeneous, and then the differences between elements, mixtures, and compounds. Now, this video will cover separation techniques. We'll talk about filtration, distillation, chromatography, evaporation, and more. So, before we even jump into this, remember when we talked about the flow chart of matter? Let's go back here. We have matter, and then we said, can it be physically separated? If the answer was yes, it is a mixture. If the answer is no, that was a pure substance. So the things we're talking about today is how to separate different mixtures of things. And so that is what we're doing here. And so here are some of these separation techniques. We have filtration, magnets, distillation, chromatography, and dissolving. And so using these things, we can manipulate the different physical and chemical properties that different substances have. So here's kind of an overview of what we're going to talk about. So let's jump into it. Now, filtration is something that you probably already have done in your life. It separates parts of a mixture by size. So filtration goes by size. And that large objects won't fit through the filter. So if you have water and sand, if you pour it through a funnel with filter paper, the sand gets stuck. So sand is going to be your solid. Your solid gets stuck because it is too big. So this is one of the easier ones to see. If you have a solid in water, water goes through the filter paper because the water is much smaller, and all that solid stuff gets stuck behind. And now you got your two separate pieces. If you think about making pasta, if you're going through some dirt or sifting through that, pasta's too big to fit through the holes in the colander, but the water isn't. So again, you've separated your water and your pasta. The next is called distillation. And so the important fact here is that distillation separates liquids based on boiling point. So that is the super important part here. It separates liquids on boiling point. So what happens in this picture, you have a mixture of alcohol and water. So just the rubbing alcohol you put to on your skin or to disinfect things looks like water, except it smells different. You have this clear liquid. Water is a clear liquid. Now if you mix both those clear liquids together, from just looking at it, you may not see that you have a mixture, but you do. And you might be thinking, oh, well, I can't separate it. Guess they're stuck forever. And the answer is no. You can separate them. And the process is distillation. So you have these two liquids that, look like one new liquid, but you can separate it, which makes it a mixture. So it uses the different boiling points of your substances. So you have a little flame or some kind of heat source underneath that mix of a liquid. Now, ethanol has a lower boiling point, so water boils at 100 degrees Celsius. Ethanol, which is the alcohol that we're talking about, has a boiling point of, it says it right here, 74.4 degrees Celsius, so much lower than that of the water. So this heat source, it heats up that mixture of liquids, and with that, the ethanol, the liquid gets to 74 degrees, and ethanol is like, okay, bye, I'm gonna go become a vapor now, and starts evaporating. Because when something boils, it goes from a liquid to a gas. You have that phase change. Now, you have gas version of that ethanol coming up this tube. Now it's blocked and has nowhere to go, but it must follow this pathway down. Now in this pathway, it's surrounded by cold water. Now cold water is supposed to cool down that gas and then convert the gas back into a liquid. So you get those condensation drops, and after a while, the ethanol drips down into a separate cup. So you have now your pure water, your pure ethanol, all set and different. Now, again, it's kind of a difficult concept to think about, but as long as you are okay with the fact that distillation separates liquids based on boiling point, you are good. Just a common use of this to obtain gasoline from crude oil. This is what goes on. Okay. Chromatography is probably something you've seen in living environment, and it separates dyes based on molecular polarity. And so in living environment, you probably didn't cover what molecular polarity is, and we'll cover that later on this year. But just depending on how molecules interact with each other and how they're actually built, that determines their polarity. But for right now, all you need to know is that chromatography separates dyes by polarity. Again, what polarity means, we'll save for later on. Okay, now this is one of the most common ones, is evaporation and dissolving. Now, if you had a mixture of salt and sand, and you had to separate them, what would you do? Now, sometimes you have to add another material to your mixture to make this possible. Now, if you had salt and sand, there is no way you're going to individually, with your finger or a tweezer, separate salt and sand. That's not going to happen. It's not going to be very reliable or accurate. But salt is capable of doing something that sand cannot. Now, salt is able to dissolve. So we're able to use one of those physical properties of salt to help move forward with this separation. So we're going to add some water. Add some H2O. And that's what we get here. Now, when you add your water, all of the gray circles, which were your salt, they dissolved and are evenly scattered throughout the water. Now, you have that sand on the bottom. So now you might be thinking, okay, well, I'm still nowhere closer to separating my salt from my sand. I've just made more of a bigger mess. Now, what you would want to do then is, because you have, let's put the sand here, and you have your salt water. Your salt water would pass through, and your sand gets stuck in the filter. So even though you had to kind of take that extra step of adding water to your mixture, that brought you closer to separating your salt and your sand. So again, you want to add water and stir to dissolve that salt. Sand does not dissolve, otherwise beaches wouldn't exist. When you pour that salt water sand mixture through a filter, that solid sand, because it's bigger than the dissolved salt, gets stuck in the filter, and that salt water passes through. Now you're like, okay, well, how do I get the salt out of the water? The next question, what you would have to do is evaporate the water. So you could boil up the water if you wanted to do it quickly. If you wanted to, let it just do it naturally over time, water will evaporate, leaving the salt on the bottom of your beaker or whatever container you were using. So here we're able to use both evaporation and dissolving. So that's pretty much all the separation techniques we're going to cover. Let's just, go through some of these together. So you have some muddy water, and you let it sit from 1, 2, 3, 4. And so now you have water with your solid mud rock stuff on the bottom. Which separation technique do you think you would use to separate the solid from the liquid? If you were thinking filtration, I would totally agree with you. You'll pour this through a filter, and all of your mud gets stuck, and all the water comes through. Next, we have separating gasoline from, this should say crude oil. All right, here you would say distillation. Again, that's separating different liquids based on their boiling points. Separate liquid based on boiling point. Also, separating gasoline from crude oil, that is one of the most real-world applications of it. Here we have leaves in a swimming pool. How would you get this out? You might say, some kind of strainer or some kind of filter. Take a giant net. All of the leaves will get stuck. Water will come through. Got yourself a clean pool. So some kind of filter would work quite well for this. If we had sugar dissolved in water, what would you do? How would you get that sugar out of that water? And hopefully you'd say evaporate the water, leaving behind the sugar. Now, if you were to boil this off, you'd actually cook your sugar and get a very, very sticky, caramely mess in your beaker. But that is what you would do. And lastly, what separation technique would you use to determine whether a coloring in a fruit juice is a single substance or a mixture of colored substances? So, if we're talking about coloring and food dye is your key for chromatography. Like that. Again, that's all you need to know about chromatography at this point. It's used to separate dyes. Okay. So that is it for this video. Next time we'll cover physical and chemical properties, physical and chemical changes, and hopefully that will make some of the things we talked about today make a little bit more sense. But on that note, have a wonderful day.